This talk came as a continuation of our research into adding support for different sources of the identity information. We started originally with Azure AD, but then quickly realized that it's really generalized into any OAuth2 identity providers, and there's a lot of them and a lot of uses for this in the academical environments, in the research institutions, and really all around the world. So we tried to figure out the kind of requirements that POSIX environments would put towards this kind of integration. And the result is this talk and the talk that will be tomorrow. And they look at different sides of the same problem. So identity management and authentication for those two. So we are working at Red Hat, mostly in the identity management area. And the third one, who is not listed in the slides because, well, it wasn't listed in the sambaXP kind of proposal because the form only allow it to put two, is the Sumit Bose from SSSD team, who is actually doing a majority of this work on SSSD side. And I would like to do a bit of reminder here, so forgive me for maybe stating obvious things, but it's worth to remind that there's fundamental differences between the way how we run identities between really these different use cases. And so in POSIX environments, we really have stable information to run processes in these environments. And these identities, they kind of enforce it through semantics defined in the POSIX standards. Now, most of the POSIX standards is probably have kind of went through a lot of real life divergences in the what we see today, but they still use and rely on the fact that, for example, file system access on the local file systems is arbitrated with IDs in the kernels, not with the names of the users or groups. These IDs get resolved by the operating system, and whatever user is seen as a username has nothing to do with how operating system stores this access control, for example, and enforces it. Same with the identity metadata, what shell to run at login, how to find home directories, and so on. This has nothing to do with the kernel itself. It's all abstractions on top of it. And that's what we have is typically what is used in the enterprise environments with traditional workstations and servers, where users have more or less the same UID, GID in all machines they log in. The data that is stored locally under different user group IDs, they belong to different users from the operating system point of view. While if you look at the typical non-POSIX environments, like OAuth environments, you don't really see any of the attributes that you would associate typically, again, with the POSIX users. So there may be a username, but that's not the name really that you would see in the default claims for OIDC Connect specification. The UID and GID numbers, they are nowhere there. There's maybe a description that can be mapped from something. There's obviously no home directory and shell in these OIDC Connect claims and so on. So it's all totally different, and you cannot really get that information as it is from the standard OIDC claims. And then the next part is that to access this information, even if it's not really something you get useful for POSIX, in order to access it, you need to be authenticated. In POSIX environments, you also need to be authenticated. So SSH server or console login process, it needs to know the POSIX identity of the user before it authenticates you. But at the same time, the identity provider, when giving you out some information about the user, it requires you as a client to be authenticated and a user consenting to give this access to this information. So roughly, if we talk about correspondence of concepts, the client OAuth2 client or IDC client identification is roughly similar to host enrollment into enterprise domain. You get possession of some credentials that you can demonstrate to the identity provider to claim that, yes, I know who am I, to give me some authorization to handle users' data. And obviously, since this client identification requires certain credentials, they need to be guarded on the host side, because if anything non-trivial is exposed through the permissions, the host being possessed by a third party opens ability to do something against that identity provider that's not probably what was meant there. So, for example, in the case of integration with Azure AD or Entra ID, Microsoft requires that you really have the trusted platform module, and you bind your access to hardware crypto for this reason. And in order to get this authenticated access, you obviously need to have these kind of client credentials for the host. And the simplest case, you can create OIDC client credentials for the host. You can do this with the public identity providers. For example, you can create your own OIDC client for, let's say, GitHub or Google or Azure in the tenant that you have permissions for. And then you can use that. But imagine you're deploying 10,000, 100,000 machines. Each of those machines have to have their own client credentials if they really need to be seen as a separate entities. That quickly becomes a sort of a nightmare. So, for example, with the Entra ID and an Intune service, I think Microsoft has some pre-authorized private credentials in Windows, or IDC client credentials that all Azure tenants trust and allow to operate in their environment. And obviously, we cannot use those. Everybody else needs to register their own clients and use. And in the case of the Entra ID, there is a lot of additional exchange to sort of protect the data and use that. And I would point to the David Mulder's talk, which will be tomorrow, for more details about how to get there and how register machines and so on. I will not be talking about this part today. So what we get really when you enroll a host as to the IDP, you really get an OIDC client. So it's an open connect client that can issue requests to the HTTPS endpoints and ask for certain operations. And it can process the data to retrieve the metadata you need. As I say, there's no metadata strictly associated with the POSIX information, so you have to effectively invent a new one or extend the schema and store that data somewhere. But you can request, for example, authorization of a user against that identity provider. And you can use that authorization to delegate authentication of a user on login to your system. And that means that the actual authentication would happen by that identity provider, not by you. And typically this is done in browsers. And of course, if you have a browser, you do a redirect and the user goes there and performs something. So you get authorized to access some information. And by this, you derive that the user was properly authenticated by the identity provider and given access to your machine. And the other part is that this all happens online. So you cannot do authorization of the access to the identity provider view of the user data offline, because you have to talk there. So offline login is directly not possible with this one. You have to use other methods. So on the fact that you were, for example, granted this authorization some time ago, you can convert that into your own representation of that authorization, your own local token. And for example, you can convert this into Kerberos tickets and use these Kerberos tickets locally until they expire. And you can bind that expiration to time while your OAuth token expires. Still, the whole operation is inherently online. And of course, if IDPs have this POSIX information, we can simply fetch it, but no IDP provided any POSIX information so far. It's a greenfield. So one possible solution is obviously to create some sort of a web application that handles this POSIX information, pretty much similar to how it's done with anything else, like storing data in LDAP or so. And then you can use some additional details and store them for the users and so on. But there's no such application created. But if it would be created, then that would be useful, because it can be used by literally everyone for independent on how exactly they access this application, because, well, it's APIs that may be accessible in the more or less standardized way, well, how we define or document them. The other way is you can store this POSIX information locally, obviously, and allow administrators to adjust somehow, pull that system configuration from, again, some application, self-provision yourself, and so on. But of course, that's not our case yet. There's no such a POSIX OAuth application for the management, and we have to do something. And as we do with when we integrate with Active Directory, we basically synthesize POSIX information. And the other part of like what you do in the identity providers world is that this common thing is the federation. So you can have identity provider that basically serves as an arbitrage for other identity providers. So your user is defined in Google, GitHub, GitLab, whatever, and you use identity provider on your premises that basically redirects the user to talk to their own source, like to Google or to GitHub, and authenticate there. And your own identity provider serves as OAuth client to those identity providers. And therefore, you get coming back with the authorization to access the data and so on. So some claims from federated identity provider response, they can be used to fill in gaps or user claims in your own identity provider. But there's no way to know a origin of those claims and trust them in reality. Now, there is draft ongoing for sort of identity chaining. It sort of helps making ability to imitate what we do in Kerberos with cross-realm trust and SVU extensions and constraint delegation and so on to show the line of trust cryptographically assigned towards the place. But it's way far away from being real implementation. So, and the most important part here is not that this exists or could exist, is the most important question is, do we actually trust the information we obtain it this way, specifically for POSIX reasons? Because if we got from a GitHub a claim that this user has POSIX UID 0, should we trust that in our environment? And does it mean that this user must be a root on a particular machine in our environment if you map this? So it's kind of an open question, what to trust, what to do. But in general, OAuth and identity providers, they work a lot with the user-facing applications to solve these kind of problems. There's a lot of research and a lot of investigation around this, and I think it's promising part that can be solved. So again, coming back, how we can handle this if we don't really have any POSIX information. Let's say we do algorithmic mapping. We basically can do this by the same way we do with auto allocation or auto mapping in Samba and SSSD. So this is SSSD mechanism that is currently in use. So we have like bunch of ranges with some slices, and we use some hash to find out which slice would be used, and then use some attribute value from the entry to identify how we positioned within that slice, and then basically define the POSIX ID as a sum of the start of POSIX IDs for that slice, for that range, and the offset in it. So hash is configurable. SSSD is using murmur hash with a common seed. CMO, some, I think like 15 years ago, used that beef constant for the seed, for the murmur hash 3, and that's what is used nowadays. So it's more or less stable. If you have like 200 IDs in your domain, you will get them all covered. But of course, if you need to expand or take a different slice, the slices might occupy, one domain might occupy more slices and so on. So for the offset calculation, there's another function or another hash that is used is really an identity function of the relative ID of the object's relative ID. But for the OAuth objects, we cannot use read because there is no read in the OAuth data. So you can use some attribute. And one scheme we came with is the use of either UUID or GUID and then hashing it. The other one is using some parts of the fully qualified names. So for fully qualified names, for example, I made a small program to simply demonstrate this. If I have, let's say, 10 ranges where the first number in this is the start of the range, the second is the size of the range. So if I use murmur hash for the domain name as the, or in this case, it's an IDP suffix. So for example, sambaXP.org is the IDP suffix, and then the username is used there, then I would get the offset, which is the last number in each user line. So for example, here it's at 28,744. That would be the offset inside the range. So the actual UID or GID in this case, because we are using OAuth private groups concept where each user has the same group ID as the UID, would be this 1,428,744, and that would be just range 6 out of these ranges, or slice 6, and so on. So you can see that they all have the same offset, regardless which domain they belong to, but because they belong to different ranges, they have different UID, GID pairs, and so on. So you can handle this with the idea that this mapping is more or less stable, and it will work on multiple workstations without any additional requirements from identity providers. The downside is that it doesn't give you ability to have username aliases because they will have ID collisions there. And I guess this needs to be handled in the actual software. Either you allow these collisions and basically treat them as aliases always, or you don't allow collisions and then you don't allow aliases. So if we look into how this presented in Samba, then we basically have two mechanisms. So one of them is loaded into WinBind and resolves this information through ID map modules. And we have three modules that can be used already. So one of them is ID map PassDB. That's the default loaded one, I think. And it basically looks up the seed and other parameters in the PassDB backend, which is TDB SAM by default, right? And then lookups the POSIX IDs in the system get PW NAM, get GER NAM, and so on. So you get a combination of IDs that expose it in the operating system and also get the attributes that Samba needs from Samba own database. This makes use of both SSSD and David Mulder's Himmelblau project possible in the standalone mode. But obviously somebody needs to fill in those seeds in TDB SAM in advance. In the case of ID map NSS, you can do lookups through NSS and then lookup seed through the domain controller with the help of WinBind. But this will not work in the standalone mode, because in standalone mode, we are not enrolled into any domain. So it kind of a special case. On the other hand, ID map SSS would work in both standalone mode and in domain mode, because SSSD presumably any any SSSD identity provider that can do seeds can be used with IDMap SSS and can deliver this information. Of course, it would not work in the standalone mode alone if you don't run WinBind. But if you run WinBind, it will not be different from the other thing. So we sort of have a starting point that if something provides this information, these POSIX identities out of OAuth identity provider, for example, Himmelblau or SSSD, then we already have Samba somewhat operating with these identities. It doesn't cover the question of how you authenticate to Samba, but at least Samba will be able to spawn processes under your identity and perform something. So this is so far so good, except the fact that even here, you can see that for a same environment, you might have multiple identity providers registered on the system, and therefore multiple domains, so called, or multiple ranges represented. And that is an interesting part, because if we look at the IDMap API, the way how it's constructed in Samba, IDMap really represents a concept of a single domain with a single ID range. So you cannot have like 10 ranges representing one domain, then slices, even 2 slices. It's just one slice. And that means that if you have an environment where you have multiple domains or multiple slices per one domain, you would need to explicitly define a range that is a not true range for this domain, but covers all slices, so that this domain get all the requests from WinBind for these domains IDs sent to this ID map provider and so on. But it would be probably best to have support for multiple slices for the same domain. The other need for this is if you have environments like in research institutions, if you have like multiple machines in a cluster, and some organizations get added to access that cluster. Right now, if you run Samba on every one of them, or WinBind to resolve these identities, then you would need to manually modify smb.conf to provide all this information. And if a new system or a new organization is added, you will have to rewrite all these configs. This adds a lot of administrative burden. Would be great to have things like when we integrate with SSSD, SSSD is able to dynamically discover all the domains it has information about, and all the ranges or slices of those ranges for those domains, and automatically expose them through the single ID map provider for all of them. And so this is kind of a good starting point, but we still have to do something. And then what we do with the seed, if we don't have a seed from OAuth identity provider, we need to generate it. So we need to kind of create some domain seeds. And if we are running already on some domain enrolled machine, we can probably map that user to the existing domain user, and therefore reuse the domain seed and all this seed. Or if this is to be seen as a user not belonging to domain, but rather a user existing on the local machine and therefore having access only locally, we might define seed based on the properties of the identity provider itself. Same with the standalone. We can map to the local machine seed and have a read within that local machine seed. or define seed based on the properties of the identity provider. This is not done yet, so it's a work that needs to be done. Then, of course, if we have all of this, we can control who can log into a particular account on that machine, who is authorized to use PAM services, who can raise privileges to run sudo, and so on. So these are actions that we can do, and it doesn't really depend whether our mappings come from identity provider or from a local source. This will work pretty much the same way everywhere. Of course, if you wanted to do some sort of a centralization of the access control, you would be interested in maybe delegating some of these decisions to the actual identity provider. And then that means using some APIs that OAuth endpoints give you on that identity provider. But there's no standard way of doing it. So all of those identity providers have their own ways to do resource control and access control and claim success and so on. So you can try to adjust for a specific environment. The other way is, or the other thing we need to look into is the actual authentication. So we need to log into the system, and we need to, if we're going to use the identity provider to do this authentication, we get to a challenge. This typically a browser-based flow, and as such, it needs then a browser before login. And that's an interesting story because it's the same as we had like in 2016, right? Remember captive portals, everybody visiting a hotel, connecting to the Wi-Fi in a hotel needs to log in over a network, needs network access, and network access needs to solve the captive portal handling. So if you're not using local users to log in, you're using corporate accounts and so on, you stuck. So in this year, we get pretty much the same situation, only that you cannot use the browser still before actual login. And you can get to the OAuth flows that allow you to use something else. And in 2024, we have browser on the phone, so we can kind of delegate authorization and authentication process to that third-party browser. And that's what we demonstrated last year at sambaXP, how it works with FreeIPA. So SSSD actually provides a pre-authentication mechanism that IPA uses in the KDC backend to use the device authorization grant flow against identity providers. And you can look at the demo I had last year, and the demo link will point you to the point where I was showing this demo. And as a result of that login, you actually get a fact that in the session you have a Kerberos ticket. You can do reuse of that Kerberos ticket for all the other accesses. For example, you can use Kerberos ticket to authenticate to PAM services, and that will give you sudo access without re-authentication or local SSH access or remote SSH access. I mean, local from this login session to other machines or to the same machines. And then browsers can use this to sign on seamlessly to services from the same organizational domain. That's if you have Kerberos and you're enrolled into enterprise domain. That's what you can do, even if you delegated the kind of check of the authentication to identity provider that has no idea about your Kerberos domain. And that's nice, but it's kind of a complex setup. And on the other hand, it allows us to avoid teaching all these applications to learn new tricks, learn how to authenticate against this identity provider. So for Samba, this will be not a problem then, because Samba knows how to use Kerberos for authentication, and you can reuse this for all the other stuff. And this is effectively what we achieve. But the downside is that, you need free APA full-blown environment for this. And that's not what many people wanted to have, especially with this IDP integration. So tomorrow I will, together with Andreas, talk about the authentication part of this. But there's a lot of changes that we will need to do. And I hope that we could have at least a demo of what we have. But we haven't yet reached the point where we can basically run SSSD with these identities sourced from Azure or Entra ID. We are close to that. So Sumit already wrote a code that fetches this information and transforms it, but not yet fully integrated into SSSD. So this work is still to be done. And on the Samba side, if we're going to use Kerberos for this kind of transformation, then we need to make support for Kerberos, MIT Kerberos specifically, because we have OAuth integration with MIT Kerberos and not Heimdall, for technical reasons of the Heimdall not supporting needed interfaces. We need to get the ID map modules to handle multiple ranges and manage them automatically. But that's a nicer thing rather than the other part is that Samba has some peculiarities in its understanding of Kerberos, and we need to, in certain areas, handle like Kerberos happening in the environments where Samba sort of does not expect it to be. But more about this in the tomorrow's talk. And yeah, that's all I have here, and I'm ready to answer for any questions.
Less of a question and more of a comment. I think you and I have talked about this before, but it would be nice if we coordinated this time and made sure that SSSD and Winbind end up doing the exact same type of mapping, so we don't have this crosshairs of mismatched ID mapping.
Absolutely. And this is the point of a common library that we are trying to develop. It's not ready yet. But yes, we absolutely need to do just a common algorithm and a common library that allows to map all this information and stores it in the same stuff.
Yeah, Alexander, one comment here to this. So how about instead of having one library with a common implementation, just being on one of the two SSSD or Winbind doing ID mapping, and the other reaching out to the other component to ask it for doing the mapping?
So you can already do that with ID map SSS in that direction. So once SSSD starts talking to OAuth identity provider, it will provide this information transparently. The other side is what David is doing in Himmelblau. If we use the same algorithms, there will be no difference in there on how identity is mapped, depending on which library you use. You still use the same mechanism. That's why it's important to agree on the algorithms, on the mapping method there.
Will that be purely algorithmic, or I doubt that this will be able to be put into a library that doesn't talk to any network, to any database, to anything else. And so I just doubt that anything of this complexity can be done in a common library. So
what I'm talking about for the common library is algorithmic mapping. So you have inputs in it, and then you have an algorithm mapping that you use the same way in all these backends. That's the only thing we can agree on. So given that you have the same input, you get the same output. That's what.
Yeah. My only concern is that there might be requirements to look up a database, to actually talk to the identity provider, to stuff. I mean, we have our ID map TDB, for example. We could do stuff there. I really have to reinforce that we need a way to, in both directions, talk to each other dynamically. And I would love to see, and this might already exist, I would love to see a protocol that SSSD provides for ID mapping, so that we don't have to always recompile ID map SSS when SSSD changes. So we need a standard protocol here so that we can ship something in Samba and replace Samba. And it's just that I want to express my doubts that this can be done in a shared library.
Maybe not. I'm still not. I mean, we haven't settled down on anything with the specifics of it. On the mapping, that's as much as we have. But for the protocol, maybe let's work on that. What specifically is needed for WinBind to request from SSSD or to require from SSSD to perform that you think should be there as a protocol?
Yeah, so just if I may summarize, it seems to be kind of agreeable that we think there should just be one place where it's implemented. So we shouldn't have two competing daemons basically implementing ID mapping. But this could be done either by having one implementation inside the library that could be used by either, or by having a server on the network that is reached out by the other, basically. That's what you're saying.
Michael,
yeah,
there will be competing implementations.
Yeah, there will be competing implementations.
And so we just need a protocol that everybody can talk to everybody else.
And that's what I meant, that we should avoid the competition.
WinBind will do it. It's just a matter of fact that we have a common history here, or an uncommon history here.
Right now, ID map in WinBind is basically operating on seed and UID, GID level IDs. Those are the things that kind of drive what is being asked. If we would expose more details there, I suspect it will become a combination of POSIX and SMB properties, maybe even more properties in a generic way, and ask, like, I want to derive these properties based on these properties as a part of protocol. Then maybe that would allow different implementations to cooperate on it. Because right now, this cooperation boundary ends at, hey, I have a seed, give me ID. Hey, I have ID, give me what? Seed. That's all is there as a protocol right now. But it's probably not enough for more complex situations.
And that's probably true, but I'm sure that SSSD will have its own requirements and its own implementation, and Winbind will have different requirements. So I just hope. I just can ask for actual cooperation and communication, but we have to prepare for diverging implementations, I guess.
Mm-hmm. Yeah, and my hope is that.
Sorry to interrupt you, gentlemen.
Yep.
We're running out of time.
Just maybe 15 seconds to complete my.
Sitting in there, starting.
By the time we get really basic write-up of all of this, publish it, we can then cooperate on making a common thing in, like Steve was saying about RFC, maybe not RFC, that's too heavy at this point, but a common document we agree and maybe disagree on certain things and document the common protocol on it. I agree we need to do that. Yep. So thank you.